Hi everyone, welcome. Um, so, based on last class, we were able to understand everything that has to do with the Stellar Consensus Protocol. And in fact, we were able to see how the Federated Byzantine Agreement works, how the SCP used this model for the consensus mechanism. We are also able to understand what the encouragement for the validators was, as the validators on the Stellar uh, protocol do not get incentivized monetarily. So we were able to understand what the encouragement was for validators to join the network. We also understood the properties that the Federated Byzantine Agreement that Stella uses kept in place to put the consensus mechanism up and running. Also, we went back to understanding the stellar prioritization when it comes to the consensus block and what it chooses, the security it chooses over speed. Next, we are also able to discuss what the quorum set is. We understand what a quorum meant and how a validator needs to have a quorum set. We also understood how it is important for validators to trust their quorum. Then we went on to understanding what threshold was and what a quorum slice is. Next, we got to understand what a node blocking set is and the impact of a node blocking set. We got to see that, okay, when there are certain node blocking sets, then it is very hard, or it is in fact impossible for a transaction to be validated. So those are part of what we learned during the last class. Also, we went on to see how many nodes should be added in a quorum. Then we went on to see the processing of the federated voting system, how a transaction is being added to the block. We were able to see that how the validators in this context of the validators, how they are able to validate a transaction that is added to the block. Then we also got to understand what a nomination protocol is, what the ballot protocol is. Then we dived deep into the stellar structure, where we understood what the ledger is, the components in a ledger, and we understood how the ledgers are connected to form the stellar blockchain. Then we got to see the accounts, what an account is, a liquidity pool, the contract data. All of these are part of the data entries inside a ledger. We got to understand all of these definitions. So today would be an interesting one, as it is in fact one of the building blocks for developers specifically. Today we'll be talking about the Stellar smart contract, building a smart contract on the Stellar, that is the SOROBAN integration. What exactly is the SOROBAN introduction? What exactly is smart contract? If this is the first time you are hearing the word smart contract, and what does it have to do with SOROBAN? SOROBAN is the smart contract for Stellar. But what exactly does this mean? This is what we'll be discussing today. Our discussion for today would not include any writing of any code. Rather, it would include understanding the fundamentals of a smart contract, understanding what a smart contract itself is. In fact, throughout this week, we would not, in fact, start writing any code. Our coding section, our in depth coding section, would start next week. So, just as a form of reminder, we will be having a test, a quiz on Thursday. And this quiz is a quiz that is meant to help you understand what your current level is when it comes to the Stellar blockchain. Now, we've dived deep into so many important properties of the Stellar blockchains, things that even as a protocol engineer or a smart contract developer, a blockchain developer, things that are very fundamental that helps you stand out as a developer. All of these are the things we've been able to understand during the course of these lectures. So this quiz we'll be having will be able to help you understand that, okay, what exactly is my progress? And also it will help us also determine those that have been faithful to the end, those that have joined the lecture, and those that deserve to get the NFT to show that they really attended the lecture. So it's going to be more like adding up the different exercises we'll be giving, because the moment we start the writing code in proper, uh, different exercises would be given. And in fact, some classes it would be exercise all through. I would not even be the one sharing screen. You would be the one sharing screen, where we are trying to solve your code problems and all of that. So we look forward to that. I want you to, in fact, look forward to that, as that would be a very interesting part of the lecture. So that's that on that. Now, moving on to what we have today: smart contract on Stella, SOROBAN integration. What exactly is a smart contract? Well, a smart contract is a self executing contract where the terms of the agreement are directly written into lines of code. What does this mean? Self executing contract. This means that a smart contract can be written in any language that the blockchain supports, whereby certain functions are written and these functions are executed to perform certain actions on the blockchain. So let's say you want to build out a kind of application whereby it's going to be an escrow. So now you can use a smart contract to do that. You write the smart contract that, okay, we want to ensure that this particular person has sent in his own token before this token goes out to this person. That smart contract would only activate sending out the other token if and only if this token comes in. So we can basically call smart contract as a bunch of code that are executed whenever certain requirements are met. So basically, this contract execute and enforce terms of condition laid within them. So it is whatever you put in your smart contract does. It's just like the saying, where you lay your bed, so you lie on it. That is exactly what the smart contract is. The smart contract, you basically write a set of instructions, and the smart contract would work based on those set of instructions. So now, if you say that, okay, until this so amount of tokens enter this contract before the other amount of tokens enter, if you send less than the amount you say you should take in, then the other one would not send out. That is basically smart contract. These lines of code are one irreversible. So whenever a smart contract is deployed, the smart contract is irreversible. What does that mean? And what does it even mean to deploy a smart contract? Well, as we go further in this lecture, we will understand what deploying a smart contract is, what initialization of a smart contract is. All of those are what we'll be learning in today's lecture. What is Soroban? Well, every different blockchains have smart contracts written on them. Now, this is different from certain blockchains because certain blockchains do not facilitate or allow for building of smart contracts on them. Why is this so? This is because such blockchain do not have what we call a virtual machine. And this virtual machine is where execution of smart contracts is being done. Example of this is Bitcoin. Bitcoin does not have the opportunity for you to deploy a smart contract on it. This is because it doesn't have an execution layer. All Bitcoin works on the protocol level is what we call UTXO. So blockchains like Ethereum, Stella are blockchains that does what? They support smart contracts. Now, you might have heard the word EVM. The word EVM is Ethereum Virtual Machine. Now, you hear some people say, I can write smart contract on all EVM blockchain. What exactly does this mean? Well, this means that the person can write smart contracts on virtual machines, on blockchains that support Ethereum virtual machines. And what language does the Ethereum virtual machine uses for the smart contract? It uses Solidity. Now, why have I gone through the route of Ethereum, the Ethereum virtual machine, to explain what we want to explain here? This is because SOROBAN is the smart contract written for Stella. So, unlike Ethereum that uses EVM, that is Ethereum virtual machine, SOROBAN is built on Stella's execution layer. So the smart contracts are executed, and that means that Stella does not support Ethereum virtual machine. And since it does not support EVM, you cannot deploy smart contracts like Solidity on Stella. So this means that Stella virtual machine has its own smart contract that you deploy on it. And the smart contract for Stella virtual machine is Soroban. I want to ensure that we are all following. Okay. Yeah. So the smart contract for Stella is what? Is Soroban. So Soroban is the smart contract platform integrated into the Stella's core protocol, and it enhances the functionality of the Stellar network by allowing developers to write and deploy smart contracts. Well, Soroban was named after the traditional Japanese abacus. Quite interesting as it traces down to some of Stella's story, because Soroban brings precision and efficiency to the Stellar ecosystem. Now, during one of our past class, we made mention that Stellar have a decentralized exchange, that's a DEX, inside built on the protocol itself. Now, that is one of Stellar's core um, protocol. But then it allows for, I heard a sound now, just wanted to be sure. Okay, okay. So the Stellar Soroban is what you literally use to build smart contracts on Stellar. So what exactly is the importance of smart contracts in a blockchain? First, smart contract automates processes and it reduces the need for intermediaries and thus lowering transaction costs. They enhance transparency and trust since transactions are recorded on the blockchain. And these transactions that are recorded on the blockchain, we are going to see in today's class what transactions look like. We're also going to see what a transaction is comprised of. Then we're also going to see how to check for transaction. We will get to understand what a transaction hash looks like and how you can search for a transaction hash relating to a particular transaction. So these are part of what we'll be understanding from the lecture we'll be seeing in today's lecture. So smart contract also provides increased security by eliminating the potential for manual errors and fraud. So unlike the normal web 2 whereby you write certain applications and yeah, people that use SQL injections and they try to manipulate your code, it's different on the smart contract. Once a smart contract has been deployed, all the set of instructions written in the smart contract as code are exactly what will be used. So all of these functions that are inside the code, which will be understanding what WASM in the case of Stella is, we will then understand how this works with the seller smart contracts when being deployed. We, every single thing written in the Soroban is what will be executed on the Stellar blockchain once deployed. Different set of instructions would not be implemented, or you cannot write like five functions, probably buy function, sell function, escrow function, and other functions like that. You write five, and then you go and call another function that is not there on your smart contract after deploying it. No, it can't work. So the exact instructions written in your smart contract is what would be used. SOROBAN overview. SOROBAN is Stellar's native smart contract platform designed to leverage the network inherent strengths such as speed, cost efficiency, and scalability. SOROBAN basically allows developers to write decentralized application that can run on Stellar blockchain. And this is what we have spoken about. So it allows a broader scope on what you can do on a blockchain. So remember, we said the blockchain has a native token, and this native token you can basically use it to you send to someone, you also receive. But then are there other bigger things we can make use of when it comes to the blockchain? Well, interestingly, smart contracts allows for this, and in Stellar's case, the smart contract that allows for this is the Soroban smart contract. So please give me a second. I want to quickly do. So yeah, sorry for that. Okay, there's a message in the group. Okay, so thank you, Eniola. Okay, back to this. Now, what are the key features of Soroban? First, secure execution. It ensures that the smart contract run in a secure and isolated environment. What does this mean? This relates with what we have made mention of earlier, that every single line of code written in your smart contract is what will be used. So unless you write a buggy code that is not audited, which we would also be discussing what it means to audit a code before pushing the code for deployment. We will understand why it is important that you even, in fact, this is what we have discussed sometimes ago, why it is important to, deploy your smart contract on the test net or future net to test it due to bugs. Because as developers, you cannot say you are so good that you cannot make mistakes or write bugs in your code. So there are certain situations that might lead to this, and that is important. That is why it's important to have security auditing. And in fact, it's another topic for another day. It's a different lecture on its own, how auditing is done on a smart contract. We would get to understand this. So next, another key feature of Soroban is the low cost of transaction. So there are different blockchains whereby to deploy the smart contract on the blockchain, the cost of transaction is quite high. And for example, the Ethereum blockchain. Now, based on the Ethereum price right now, the price for deploying the Ethereum smart contract, deploying a Solidity code on Ethereum is quite high due to the price of the native token. That's the price of the token you use for the gas fee. Now, for Stellar, it is quite low. Apart from that, whenever there's a surge or increase in transactions, the prices in native blockchains like Ethereum goes up. Although different Ethereum improvement proposals that have been done or kept in place, like EIP 1559 on Ethereum, that have allowed for lower gas fee, that has moderated this, but this did not still, in effect, reduce the price sometimes to deploy smart contract there, especially when prices of the native token goes up, this goes up. But compared to that on the Stellar blockchain, there is low cost for transactions. So when we talk about transactions, deploying the smart contract is a transaction. Writing a call to modify the state of the smart contract is also a transaction. And all of these things requires payment of gas fee. And this gas fee in Stellar case, as we made mention of, one of the key features of Stellar is that the transaction cost is low. Another thing is developer friendly. So Stellar supports multiple language, and it in fact provides comprehensive documentation, as this lecture is one of the um, um, opportunities Stellar has given out to developers, to build on the blockchain. So it supports different languages um, for the SDKs, and also for the smart contract. It basically supports the SOROBAN, which is Rust. It's a framework that was built on Rust. What then are the benefits of using SOROBAN on Stellar? One is enhanced functionalities. What does this mean? This means that it adds complex programmable logic to the Stellar network, allowing for more sophisticated financial products and services. So basically, the fact that you can build your own idea using a smart contract and deploying this smart contract on the Stellar blockchain means that you can literally, the sky is your limit. You can literally think of anything, and anything that you think of, you can implement all of these things, and all of these things you're implementing is what will be deployed on the Stellar chain. So if you think of blockchains like Bitcoin, the only thing you can do on Bitcoin is to transfer Bitcoin from one person to another. But on Stellar, you have the opportunity to build a smart contract with your own logic, and then deploy this smart contract on the Stellar blockchain. And the smart contract then leverages on the security of the Stellar blockchain. What are other benefits? Another benefit is the robust infrastructure. Well, your smart contract deploying it on a chain means you have to deploy it on a chain that is stable, and smart contracts deployed on the Stellar blockchain is quite mature and well established, because as we have seen, Stellar has been in existence since 2014 up till now. That is over 10 years of development stage. And all of these development stage have led to the improvement of the Stellar blockchain as a whole. And you writing your smart contract and deploying it on this blockchain is an advantage for you as an individual. So this is another benefit of writing smart contract Soroban on Stellar blockchain and deploying it there. Because Stellar, even as we made mention of in previous lecture, allows for what we call future net. So imagine a blockchain where new proposals, new additions to the core feature of the blockchain is being implemented, and developers are allowed to even deploy their smart contract with comparison to the new features that are on this new that will be implemented on the main net, that has been implemented on the future net, to show developers, this is something that allows for developers and builders to, to test out new ideas. So it's a beautiful one Stellar have done there for the future net that they kept in place. And so there's a robust infrastructure for Stellar for you to build using the Soroban network. Another thing is the community and the ecosystem support. Stella has a robust community, and one of the things the community have done is to provide resources and support for developers. And in fact, I've made mention before, this class we have right now is part of the support the Stellar community have provided for developers to build, and for developers to even learn. So it's easy for you as a developer, you have a bug or you have a problem while writing your smart contract, or you feel this feature should be on this blockchain. Well, it's easy to just come to the community, ask for support, or lay out what you think. And that is in fact why we made mention of people, individuals that are willing to join the Stellar network and serve as a node provider to the network. These people can literally push for improvements in the Stellar blockchain, and even you as individual can push for this. So I want to quickly check if we are still on track. Okay. So Moving on, WebAssembly integration, WASM. Why are we talking about WASM? What does WASM have to do with Stella or SOROBAN? Well, WebAssembly is actually a binary instruction format for a stack-based virtual machine. So it is designed to be a portable compilation target for programming languages, enabling code to run on various platforms without modification. That is what WASM is. Now, there are different languages actually that can be compiled down to WASM. And so when it is compiled down to WASM, then the WASM runs as a binary instructions. And so an example of a language that is compiled down to WASM is Rust. So for the Rust language, once you write out your Rust programming, you write out your code, the code is then it's compiled down to WASM. Then this WASM serves as a binary that can talk to your machine. In this case, where we are talking about the Stellar blockchain. Now, every blockchain that allows for deployment of smart contract on it, what we call a virtual machine. So now for Ethereum, it uses the Ethereum virtual machine. And Stellar also have its own virtual machine too. So now, whenever um, WASM, that is Rust code is compiled down, as I made mention of, there are different other languages that compile down to WASM. But whenever in Rust case, whenever Rust code is compiled down to WASM, it basically allows for easy interaction with the development environment. One important thing that WASM is known for is its efficiency, the security, and the performance. WASM is very fast, and that's exactly one of the core features of Rust. Due to the ability for Rust to compile down to WASM and for it to easily run the binary on any machine, it is very, very efficient. And this is exactly one reason why it is important or very good for blockchains to actually make use of this kind of language. And that is exactly what Stella did. In Stella's case, Stella's smart contract, which is Soroban, is written in Rust. And it's basically a framework on Rust. And so what this means that Soroban smart contract utilizes WASM. So Stella is not the only blockchain that uses WASM. There are other blockchains that make use of WASM, and the WASM, their smart contract is compiled down to WASM, and then this WASM is pushed to the blockchain, and then it is initialized, and then it is run. Example of blockchains that also use this is Polkadot. Polkadot's smart contract is Ink, and when you write your Ink smart contract, you compile it down to WASM, and this WASM is then pushed to the Polkadot network, to the Polkadot blockchain. Now on Polkadot, they have different things like parachains, but right here we are talking about Stellar. Another blockchain that makes use of this is Concordion. Concordion have its smart contracts written in on a Rust-based language. So it's basically a framework written with Rust. So then, how does Soroban utilizes WASM? Well, the smart contracts are written by the developers, and then these smart contracts are compiled down into WASM bytecode, which are then executed on the Stellar network. So I would use Ethereum as a comparison for this. For Ethereum smart contract is compiled down into bytecode. This bytecode is then executed on the Ethereum virtual machine as what we call opcode. Now, this is a different case in Stellar. Stellar's smart contract, which is Soroban, is compiled down to WASM. and then this WASM is then executed on the Stella virtual machine. So the compiled WASM bytecode is stored on the ledger, and it is then allowed to be retrieved and executed as needed. So that is why your smart contract, once you write it, then you compile it, then the WASM code is what you deploy to the Stellar blockchain. Once you deploy it, then you have ability to now interact with the deployed smart contract on the blockchain. So based on how you write your smart contract, all the instructions written on your smart contract are then compiled by to this WASM. And this WASM is what is pushed to the Stellar blockchain. And then any individual can then do what? Have access to call the smart contract based on the instructions written in the smart contract. So these integrations ensures that smart contracts are executed quickly and securely with minimal overhead. What then are the benefits of WASM for smart contracts? First is high performance. WASM is designed for fast execution and it enables quick processing of smart contract operations. If you are very familiar with the Rust programming language, one of the benefits of the Rust programming language is the speed. And what enables this to happen? This is because it literally compiles down to WASM. And then WASM can easily execute on different environments as binaries. And binaries is literally what speaks to the if you are a computer science student or you have understanding of what binaries are, you understand that binaries easily communicate with the machine. So binary is more like a language close to the machine language. And whenever you have something close to the machine language, execution is at peak. There is quick execution. And that is exactly one reason why, in fact, different infrastructures make use of Rust for their infrastructures. So they build big infrastructures using Rust. And in our case, the smart contracts are built using Rust, and this Rust compile down to WASM and it makes it faster. So I'm going to check if everyone is still following along. I want to do this periodic check so we don't have a problem like last time. So yeah. Another important thing is, or another important benefit of WASM, oh, sorry. Another important benefit of WASM is the language agonist. What does this mean? This means that developers can write smart contracts in various programming languages that compile down to WASM. And this provides flexibility and ease of use. So now, as an individual, you might want to use a different way. Like I made mention earlier, there are different languages you can use and compile down to WASM. One of the ones I personally love using very well is Rust. And that is why I've made mention of Rust so many times as a language. And another reason is that SOROBAN smart contract is built on Rust. And so you can literally write it in any one you want, and then as long as it's a WASM, you can push this WASM to the network. You can push it to the Soroban network, and then it is stored on the you can push it to the Stellar network. I mean, then it is stored on the Stellar ledger, and from the Stellar ledger, you can basically make write calls or read calls to the smart contract. Another benefit of smart contract is the security. WASM is designed in such a way that it includes strong security features such as sandboxing, which isolates the execution of smart contract from the rest of the system and is decentralized. So the WASM is designed in such a way whereby it is secured, and these security features allows for smart contract execution to be isolated. So it's not easy for someone else to write another smart contract that would attack it. It's not that it cannot be done, but it can only be done if there are certain vulnerabilities in your smart contract. But if there are no vulnerabilities in your smart contract, that your smart contract are well audited, then in that case, it cannot be easily attacked. And this is one of the biggest reasons why Stella makes use of SOROBAN, which is built with Rust and it's compiled down to WASM. And so it's a very big one for Stella. So at this pause for a little and check if there are anybody that have questions based on what we have discussed up to this point. Are there questions based on what we have discussed? Are there any questions? Okay. Since there are basically no questions for now, I would proceed. Smart contract installation process. The first thing is to definitely write the smart contract and then compile it. So whenever you, in fact, in other languages, like I said, for example, for the EVM compatible blockchain like Ethereum, the smart contract is basically written in um, Solidity, and then it's compiled down to bytecode, and then these bytecode are executed as opcode. So for Stellar, the smart contract, you write it, and then after writing it, you compile it on your laptop, on your system, and then when you compile it, you get what we call the WASM. So after compiling it, the WASM is what you now send, is what you now deploy to the Stellar blockchain. So the WASM bytecode is what you deployed. So the WASM bytecode allows for creating a binary execution file that is deployed on the Stellar blockchain. Creating a contract data ledger entry. What does this mean? This means that once compiled, the WASM bytecode is uploaded to the Stellar network, and then a contract data ledger entry is created to store the binary data for the smart contract. This entry includes a unique identifier, which is the hash of the executable file. What does this mean? This means that once you write your smart contract and you deploy the WASM bytecode to the Stellar blockchain, it returns something for you. It returns what we call the hash. So the hash is what you are able to use to identify your deployed smart contract, your deployed WASM bytecode that has been deployed to the Stellar blockchain. So this hash is what you now use to identify that executable file on the Stellar blockchain. So at this particular point, the Stellar, the smart contract has been deployed to the chain. So, but then, what exactly is a contract data ledger entry? The contract data ledger entry is what you use for this. But then, on the other hand, data ledger entry is one of certain operations that we will talk about in this lecture that is done or used for Stellar. Storing binary data and unique identifiers. The hash of the executable file serves as a unique identifier, ensuring that each smart contract is distinct. So that means that if I deploy a smart contract, the hash from my deployed smart contract is different from the hash of another person's smart contract. And this literally allows for you to identify the smart contract you have deployed on the blockchain. So you can easily query or write calls to the smart contract that has been deployed through this hash. Because if you cannot identify your own smart contract that you have deployed on the chain, how then can you interact with the smart contract? So each smart contract have an identifier, and these identifiers are hash. So then this binary executable is stored separately from the deployed contract instances. It is allowed for reuse and efficient management of smart contract code on the network. The beautiful thing about Stellar is that now, on other blockchains, whenever you write a smart contract, you deploy this smart contract to the chain. For example, I would use EVM as an example. One of EVM is Ethereum or Polygon or Arbitrum. One of these. Imagine you write your Solidity code and you deploy it on an EVM blockchain, what happens is that you have ability to write calls to the smart contracts you have deployed. But then, if you want to then create the exact same smart contract on that EVM blockchain, you have to do two things. One is either to redeploy the smart contract all over again. So that means that code you have deployed before, you have to deploy that full code all over again to the EVM blockchain. So that means that the code space that it has taken, because all of these are this bytecode you are deploying to the blockchain, they are literally taking a space on the blockchain. So this bytecode takes up a space. So if you deploy another one, that one too takes up another space. So although each bytecode you deploy gives you the contract address you can use to interact with it. You understand? So whenever you deploy this, you have to keep deploying new ones, and these new ones have their own different codes. But then it is different in the case of Stella. What does this mean? I'm getting at that. Now, for Stella, whenever you deploy a WASM code, but before I go there, let me talk about the second way you can do it on the EVM. The second one is to write a factory contract. And what this factory contract does is you basically have a function that creates new instance of that contract. So those new instances are then deployed on that contract, on that blockchain, on the EVM blockchains. So those new instance deploy new bytecode on this bytecode are the same, but it deploys this bytecode on the same blockchain. So all of these bytecodes literally keep taking up spaces, and that is why when you want to participate as a client, or you want to download the client of the blockchain and participate in the network validation of the blockchain, you see certain requirements requires having very voluminous hard drive. I cannot exactly remember how many gig you need right now to participate as a validator on the Ethereum blockchain. But due to the fact that you keep deploying different smart contracts, this different smart contracts keeps taking spaces, the size of the full blockchain keeps increasing. Although there are different mechanisms that are being used now to fight such things, and some of these whereby they are thinking of using different ZK proofs to reduce all of these things. And in fact, they think of using things like vacuum tree and other things to reduce all of these things. But this is different in the case of Stella. And that is exactly why I'll be using that as a comparison to Stella. So for Stella, Stella makes use of the same WASM code. So whenever you deploy a WASM code on the Stellar blockchain, you have opportunity to reinstantiate this same contract. But whenever you reinstantiate it, what happens? Let's move on. Contract invocation and execution. How exactly is transactions invoked on the Stellar blockchain? Don't forget what I mentioned of earlier now. Talking of how the instances of the smart contracts that are deployed, that's the bytecode that are deployed on the Stellar blockchain, how are they then retrieved? That is what I discussed earlier. But then as we move forward, we'll be seeing how these are instantiated. I heard certain sounds and I want to confirm if we are still all together. Okay, we are still all together. So moving on, contract invocation and execution. How transactions invoke smart contracts. Transaction on the Stellar network can include operations that invoke smart contract functions. So when a transaction attempts to call a smart contract function, the WASM bytecode for that contract is retrieved from the ledger. So what does it mean to retrieve the WASM bytecode from the ledger? Retrieving wasm bytecode from the ledger means that the network fetches the stored wasm bytecode based on the unique identifier that we made mention of that associates itself with the smart contract. So different hatches for different wasm bytecode that has deployed. So it fetches it using that hash. Then this ensures that the correct version of the smart contract is then executed. So now, whenever you write the smart contract and it's deployed, the version code that you deploy on the Stellar blockchain for whenever you want to invoke a transaction, what happens is that that wasm code is then invoked. The transaction calls the wasm code, and then all the functions that are inside that smart contract, inside that has been compiled down to wasm code, are being fetched, and then you can easily then modify the storage of the smart contract. Secure isolated runtime virtual machine. A secure isolated runtime virtual machine is instantiated to execute the WASM bytecode. Remember, as I made mention of, every blockchain that has ability to execute a smart contract, that have a smart contract, has what we call a virtual machine. And in the case of Stella, the runtime virtual machine is where the smart contract that has been instantiated to execute the wasm bytecode is being called. It's where it is being executed. So this virtual machine environment ensures that the smart contract runs securely with no risk of affecting other operations on the network. So while you are calling your smart contract, other operations on the network keeps going on, and so all these operations, you calling your smart contract, the execution of calling your smart contract, it is basically done on the Stellar virtual machine. And this is the environment where the smart contract is being executed. And in just one execution, you can have more than 10 calls or even more in calling just one smart contract. And all of these calls will be called simultaneously. And all of this is done with the Stellar virtual machine. And it doesn't affect other operations that is happening on the blockchain. But once operation is complete, the virtual machine exits, and then it keeps maintaining the integrity and the security of the blockchain. Contract instances. Now, if you go back to what I made mention of, giving illustration of how um, the Ethereum virtual machine, that's EVM in its own case, uses the ability to deploy new smart contract, new Solidity code, and this Solidity code keeps adding on to the block and keeps making the blockchain size increase in size. So in this case, we want to understand the difference between pushing a WASM bytecode to Stellar and pushing a Solidity code that has been compiled down to bytecode on the EVM blockchain and the execution. So now, the contract instances. What are contract instances? After the executable bytecode is installed on the Stellar network, then a contract instance can be deployed. These instances reference the installed bytecode but function independently. So what does this mean? This means that whenever you push a WASM bytecode to the Stellar blockchain, now the WASM bytecode includes the implementation of your smart contract. Now, in in the blockchain space, when you talk about implementation and storage, there are two different things. Now, for a smart contract, when you have a smart contract, the smart contract has both implementation and storage. So, modification of the storage is done by functions, that's the implementation of the smart contract. But now, in the case of Stellar, the implementation is different. It is completely separated from the storage. So the implementation is where the bytecode executable file is, and that one is then stored on the ledger on Stellar. So now, whenever you now want to like have your own DApp, you then initialize. That's you create an instance of the bytecode. Then you then reference to it to call the implementation. So that instance you create is where your storage is. To make this easier to understand, I'll be using example of a smart contract that does a simple thing. What the smart contract does is it keeps an hospital record. Now, for the hospital record have a storage whereby, okay, the amount of people that has been registered in the hospital, how many are they? But then that same contract also have implementation whereby, okay, whenever someone else is come, we are going to call this particular function. Maybe we name it add patient function. So you have this add patient function. What the add patient function does is to increase the amount of patients we have in the hospital and also register, okay, now we have this patient, this is his own profile, this is his genotype, this is his own blood type. All of this data, you then update it on the storage. Now, that implementation is the function that is changing that storage. The storage is now the file, that's the data of those patients. Now, coming back to what we are trying to explain, what we are trying to explain is that the storage of the smart contract is different from the implementation. The implementation is where the executable bytecode on the Stellar blockchain is stored. So whenever you want to have a new instance of that smart contract, all you do is to initialize a new instance. So when you initialize a new instance, the new instance you initialize will have the storage that is stored. And so it then references to the bytecode. This bytecode is what is the wasm bytecode where the implementation is. So it then references to it, and the reference now does what? Now mutates the storage of the contract based, that's the storage of the instance, based on the function that you have called. So what I've just explained, I want to be sure that everyone got what I've just explained. Is there anybody that did not get what I've just explained? Is there
Uh,
anybody that did not get
One
what
more time. Thank you.
Great, great. So that is exactly the relationship and the difference between a normal, like a different EVM compatible blockchain and Stellar blockchain. Relationship between code and instances. A single executable bytecode can be shared by multiple contract instances. So now remember when I was talking about the EVM blockchain, whereby if you want to have something whereby you initialize new contracts, all you have to do is to write a smart contract that does what we call you write what we call a factory contract. What the factory contract does is to create new instance of that same contract. So in this case in Stellar, you don't have to do that. So you can have so many contracts that are referencing a single bytecode. So that bytecode is where the implementation of the contract is. So all the functions that result to transaction calls are there. So in this case, for Stellar, you don't have to write a factory contract that does what? That reinitialize. All you have to do is write a smart contract, deploy that smart contract. That what you are deploying is the WASM bytecode of the smart contract. And once you deploy this WASM bytecode of the smart contract, the WASM bytecode of the smart contract, you can now create instances of that WASM bytecode. So that WASM bytecode can serve as what we call a factory contract in the in when you talk of the context, in the context of the EVM compatible blockchains like Polygon, Ethereum that I've made mention of earlier. In this case, you can then initialize different smart contract in this case. So each instances maintains its own state data while sharing the same executable code. So let's say me, for example, I'll say someone like Levi has his own hospital. I have my own hospital. Levi has his own hospital. Now, for Levi's hospital has a list of patients. The list of patients in Levi's hospital is different from the list of patients in my own hospital. So we can write a smart contract, deploy the WASM code. So the WASM bytecode is deployed to Stella network, and then me create an instance of that WASM code for my own hospital. So now in my own hospital, my own state storage now have amount of patients, have the patient's data, and then whenever you want to add new patients or you want to update a patient's profile, it references to the bytecode, and then it uses it to modify the storage of the smart contract. Now, Levi has his own smart contract, which is an instance of the same WASM code that I have deployed. So, in this case, my own instance can have about 100 people as my own patients in my own contract. Levi, in his own, can have 200 patients, but we both are still referencing to the same WASM bytecode that has been Stellar blockchain for implementation. So different contracts can share the same implementation. So that means that there are different um, instances of the smart contract that shares the same WASM bytecode that has been deployed. So independent functioning of multiple instances. So smart contracts instance operate independently despite the same bytecode. And this allows for scalable and flexible deployment of smart contracts. As I've made mention of earlier, you don't need to write a separate smart contract that you call a factory smart contract, whereby this smart contract is what you now use to deploy. In Ethereum, you have this factory smart contract have different Ethereum improvement proposal. Some have create one, create two. You see, all of these implementations are just implementations to deploy in the smart contract. But in the case of Stellar, once a WASM bytecode has been pushed to the blockchain, in that case, the WASM bytecode can then be initialized. Instances of that WASM bytecode can be created, and these different instances have different storage. So, are there any questions? Because this is where we'll be coming to an end for today's class. In next class, we'll be talking more of the contract storage overview, what a temporary storage is, what a persistent storage is, what an instant storage is, what operations and transactions are, transaction structures. All of these are what we'll be discussing for the next class. But for today, this is how we would come to the end of our lecture for today. So are there any questions from anybody that they would like to ask me right now on the call? Are there any questions? In this case, if there are no questions to be asked, this is how we come to the end of the lecture for today. Okay, I saw. Okay, thank you very much, Tino. I appreciate hearing that. This is how we come to the end of the lecture for today, and see you next week. Did I just say next week? See you tomorrow. I would end the recording here.